All right, this is 2.2 Ionic Bonds. It's all in the charges. Last unit, we learned about covalent bonds. In covalent bonds, electrons were shared between atoms. The objectives. Describe how ionic bonds form and list properties of ionic compounds. Ionic bond and ionic compound are a lesson vocabulary. Introduction. All compounds form when atoms of different elements share or transfer electrons. In water, the atoms share electrons. In some other compounds, called ionic compounds, atoms transfer electrons. The electrons actually move from one atom to another. When atoms transfer electrons in this way, they become charged particles called ions. The ions are held together by ionic bonds. An ionic bond is the force of attraction that holds together positive and negative ions. It forms when atoms of a metallic element give up electrons to atoms of a non-metallic element. The figure below shows how this happens. Notice sodium has one valence electron. Chlorine has 7 valence electrons. If sodium gives its electron to chlorine, then sodium will have a full outer shell, chlorine will have a full outer shell, but sodium will have a positive charge, chlorine will have a negative charge. The reason these charges are there is because sodium still has the same number of protons, which is one more than electrons. Chlorine still has the same number of protons, but has one more electron than it does protons. By losing an electron, the sodium atom becomes a sodium ion. It now has one less electron than protons, giving it a charge of positive 1. Positive ions, such as sodium, are given the same name as the element. The chemical symbol has a plus sign to distinguish the ion from an atom of the element. The symbol for a sodium ion is sodium with a superscript plus. That's the superscript plus area right there. By gaining an electron, the chlorine atom becomes a chloride ion. It now has one more electron than protons, giving it a charge of negative 1. Negative ions are named by adding the suffix "ide," that's basically the ending of the word, to the first part of the element name. The symbol for chloride is Cl negative. Sodium and chloride ions have equal but opposite charges. Opposites attract, so sodium and chloride ions attract each other. They cling together in a strong ionic bond. You can see this in row 2 of figure 1, the figure above. Brackets separate the ions in the diagram to show that the ions in the compound do not share electrons. You can see animations of sodium chloride forming at this URL. Ionic bonds form only between metals and nonmetals. Metals want to give up electrons, and nonmetals want to gain electrons. Find sodium in the figure below, right here. Sodium is an alkali metal in group 1. Like other group 1 elements, it has just one valence electron. If sodium loses that one electron, it will have a full outer energy level. Now find fluorine, circled in red, in the figure below. Fluorine is a halogen in group 17. It has 7 valence electrons. If fluorine gains one electron, it will have a full outer energy level. After sodium gives up its valence electron to fluorine, both atoms have a more stable arrangement of electrons. It takes energy to remove valence electrons from an atom. The force of attraction between the negative electrons and positive nucleus must be overcome. The amount of energy needed depends on the element. Less energy is needed to move just one or a few electrons than many. This explains why sodium and other alkali metals form positive ions so easily. Less energy is also needed to remove electrons from larger atoms in the same group. For example, in group 1, it takes less energy to remove an electron from francium at the bottom of the group than from lithium at the top of the group. Coming up here, you'll see francium is down here, lithium's up here. It takes less energy to remove electrons from francium. In bigger atoms, valence electrons are further from the nucleus. As a result, the force of attraction between the electrons and the nucleus is weaker. What happens When an atom gains an electron and becomes a negative ion, energy is released. Halogens release the most energy when they form ions. As a result, they are very reactive. Ionic compounds contain ions of metals and nonmetals held together by ionic bonds. Ionic compounds do not form molecules. Instead, many Ionic compounds contain ions of metals and nonmetals held together by ionic bonds. Ionic compounds do not form molecules. Sorry, I lost my place for a moment. Instead, many positive and negative ions bond together to form a structure called a crystal. You can see an example of a crystal in the figure below. It shows the ionic compound sodium chloride. Positive sodium ions alternate in negative chloride ions with negative chloride ions. The oppositely charged ions are strongly attracted to each other. This is why salt is a cube. Naming ionic compounds. Ionic compounds are named for their positive and negative ions. The name of the positive ion always comes first. For example, sodium and chloride ions form the compound named sodium chloride, also known as table salt. You try it. What is the name of the ionic compound composed of positive barium ions and negative iodide ions? Answer: barium iodide. The crystal structure of ionic compounds is strong and rigid. It takes a lot of energy to break all those strong ionic bonds. As a result, ionic compounds are solids with high melting and boiling points. The rigid crystals are brittle and more likely to break than bend when struck. As a result, ionic crystals tend to shatter. You can learn more about the properties of ionic compounds by watching the video at this URL. Compare the melting and boiling points of these ionic compounds with those of water, which is not an ionic compound. Sodium chloride, very high melting and boiling points. Remember, water's melting point is 0 degrees Celsius and boiling point is 100 degrees Celsius. So we can see that these are much higher in both areas. Solid ionic compounds are poor conductors of electricity. The strong bonds between ions lock them into place in the crystal. However, in the liquid state, ionic compounds are good conductors of electricity. Most ionic compounds dissolve easily in water. When they dissolve, they separate into individual ions. The ions can move freely, so they are good conductors of electricity. Dissolved ionic compounds are called electrolytes. You've seen this if you've ever dissolved salt in water. Ionic compounds have many uses. Many ionic compounds are used in industry. The human body also needs several ions for good health. Having low levels of the ions can endanger important functions such as heartbeat. Solutions of ionic compounds can be used to restore the ions. In summary, an ionic bond is the force of attraction that holds together oppositely charged ions. It forms when atoms of a metal transfer electrons to atoms of a nonmetal. When this happens, the atoms become oppositely charged ions. Ionic compounds form crystals instead of molecules. Ionic bonds are strong and the crystals are rigid. As a result, ionic compounds are brittle solids with high melting and boiling points. In a liquid state or dissolved in water, ionic compounds are good conductors of electricity. And that wraps up 2.2 Ionic Compounds. Thanks for listening.